guys, welcome back to another video. So this is our 12th video where we'll be discussing about ES6 classes, inheritance and promises. We will be also discussing about promise polyfills, async-await and promise methods. Right, so let's get started with ES6 classes. So in the previous last video, we have discussed about how to create function constructor and objects. So today we will be seeing about the creation of objects using classes. Although there is nothing called as classes in class in JavaScript, there is no keyword, but there is a sugar-coated syntax that we use in terms of class and inheritance. Right, so that we'll be seeing in this video. Okay, so let's get started with single inheritance. So let's create a class called animal. Class animal. Now we want to create a field inside it. So what we can do is we can use constructor and we can assign this dot name equal to name. That will be passed inside the constructor. So we'll be passing a name inside the constructor. And we can also define the functions like this: speak console.log, this dot name is speaking. Now this is how you can create a ES6 class. This was introduced in ES6. Now if you try to print console.log console.dir animal, it is going to give you a function, not a class. Right, let me let me run it inside the browser, I guess. So it is giving me a class, but if I write type of animal, this is going to give me a function. Although everything in JavaScript is either a function or an object or a non-primitive type. So there is nothing called as class in JavaScript. This is just a sugar-coated syntax over the function constructor. We can define it using the function constructor as well, right? So we have created a class called animal. Now for single inheritance, we can do something like this is single inheritance. Class dog extends. This is similar, the syntax is very similar to that in Java. So we can define our constructor over here, name, breed, and we can call the parent constructor using this and using super keyword. This dot breed will be equal to breed, and bark will be our method. Console.log this dot name is barking. Right, so this is an example of single inheritance. Now if you create an object of dog class where Labrador equal to new dog, name is Rex, and we can call the methods like this. Labrador dot speak, right? So Labrador dot speak is going to invoke the invoke the constructor of the parent class using prototypal inheritance. Now bark will be called using the, like, it is making a proto, it has the Labrador. So if I try to write it inside the browser, console.dir Labrador, you will see that this is an object of dog class. It is having the property name and breed, and inside proto is linked to an animal because we have constructed the object using animal class. Animal is having bark method and its prototype is linked with animal. Prototype is linked with animal, right? So this is having the speak method, as you can see here inside the proto property, right? So this is how it is accessing the bark and speak property using the prototypal inheritance, right? So this is one thing. This is how you create a single inheritance inside JavaScript using ES6 syntax. We have also seen this in using the function constructor, right? We have to link the prototype.proto property with the function constructors prototype to create a inheritance using a function constructor. But this is a super simple and sugar coated syntax that was defined in ES6 version of ECMAScript 2000 in 2015. So this is how you create a single inheritance using class keyword. Now we'll be seeing about multi-level inheritance. So let's say we have a class called A and it has a constructor, and I will write A's constructor, and it has apart from this print A's print method, A's print, and if I do class B extends A, I'm going to write constructor super is going to invoke the constructor of the parent, and this will be B's print class C extends B, C's constructor. And if I create an instance of C, that will be new C. Now what is going to happen is it will invoke the constructor of C. C is firstly invoking the constructor of B. B is invoking the constructor of A. So A's constructor will be printed, B's constructor will be printed, and then C's constructor will be printed, right? So if you invoke it like this is going to trigger the constructor functions of A, B, and C like this. Now if we want to print C dot print, we can do so like this. It will call the C's print, right? In order to call B and A's print, you need to define the object for that class, right? So this is also kind of overriding the parent's method. So this is you can say it like method overriding or parent time polymorphism, right? So this is an example of that as well. So right, that is how you declare the classes using ES6 syntax, using the class and extends constructor and define the function like this. And if you need to declare the variables, you can define it in the constructor. There is no need to declare variables using let and var here. You do not need to do this. You just have to use this keyword inside the constructor to define the property, right? As we have seen in the single inheritance, right? This dot name, this dot breed, and to invoke the parents constructor, you need to use the super keyword like this, super, right? So this is about the classes and inheritance in JavaScript that came up in 2015 in the ES6 version of JavaScript, ECMAScript. Now what we need to discuss is probably let's talk about how do you declare a private and static method or variable inside JavaScript using the class syntax. So let's define it like this. Let's define a class named as person.js class person, constructor name age, this dot name equal to name, this dot age equal to age, this dot. Now the private property can be defined using the hash symbol, this dot private field. And what we are going to do is whenever we invoke a constructor, this is going to basically trigger a private field, and it is going to increase the number of population of the, whenever a person object is created, basically the population has to be increased. So what we can do is we can do something like this dot population plus plus, right? So we can instead yeah, so this dot, so initializing the population using the hash symbol, this is going to create a private field, and accessing this using this keyword is going to increase its value, right? So instead we have to create this as a static property, I guess, right? So static property will be created once per one per class, not per object. So static can be defined like this, right? And to get the population, we can define a static method that will return this dot population. Reset population can reset the population of the person class, person's population. And yeah, so that's it, I guess. Display. Right, so if we create a person p1 new person John 30 console.log person.get population, so output should be 2, right? So this is how you create a static property using the static keyword and access it using the class. And if you want to declare it private, you can define it using the hash symbol, right? So instead of creating a static private property, you can just define it like this: static property, and like this. So this is going to create a static property. Now you can also define a private property like this: hash private field. This is private. This dot private field, you cannot access it outside, right? So this is working fine. Now if you try to print p1 dot hash private field, this will throw an error. And even if you try to access p1 dot what's the name, population, this is not going to throw an error, I guess. No, this is going to say me undefined, there is no such property. And if you try to access the private property, this is going to throw us an error saying that this will throw an error because private field is private. You cannot access it outside the class. So this is how you construct a private and static property inside ES6 classes. We have seen this in the function constructors as well, right? So this is the syntax for ES6 classes. So I think classes part is done. Now we'll be talking about promises. What exactly is a promise? So I will do classes, and I will move them here. Now we will be talking about promises. Let me check the stream whether it is working fine or not. Now we will be talking about promises. Let me check the stream whether it is working fine or not. So let's talk about promises now. So what exactly does a promise do? Basically, promise is a event. Basically, it is nothing, just an object that shows the eventual completion of an asynchronous task. So basically, we'll be passing an asynchronous task to the promise, and based on that, we will be resolving or rejecting the promise, whatever it is returning from it. So you will know, right? I will write the syntax as of now. So how do you construct a promise? Uh, that's the first thing that we'll be discussing now. So how do you create a promise? There's like const p1 equal to, using the new keyword, new promise promise, and it accepts a callback function which have the properties as resolve and reject. So resolve and reject. You can take any name of your choice for this part, but it is preferred to use resolve and reject. And it is going to be resolved after some time. So I will use set timeout, and it is going to be resolved after this. So whenever you write resolve, it is it will it will say that, hey, promise is the promisified part is done, and you are basically receiving a positive value, basically a resolved value. And if you use reject, then it means that promise has been rejected. There is some issue with within the promise, and that is why it is rejecting. So you can either use resolve and reject to define whether the promise is resolved or rejected, whether, right? So this is how you declare a promise. You write new promise. This is a constructor function, and inside it you pass a callback function which accepts two arguments. That is, first one is resolve and second one is reject. Now based on some condition or whatever your logic is, you can resolve and reject the promise. Now how do you consume a promise? So this is creation of a promise, consuming the promise. Now promises can be consumed via then and catch. So then accepts the callback function which has data as its parameters, data as in parameters, and then you can do console.log, and you can chain up the promises like using dot catch. If it is resolved, then it will hit the then condition. If it is rejected, then it will hit the catch condition. So right. So what we are doing is we are writing p1 dot then. So if the promise is resolved, then it will come inside this callback function. If it is getting rejected, then it will come inside this catch condition, and similarly print the output. So if we hit run, so set timeout is going to be this resolve is going to be get called after 2 seconds. So it will take exactly 2 seconds to resolve the promise. So 1, 2, it is saying that promise resolved, and I will write inside then data inside catch error. So after 2 seconds you will see inside then, and promise is resolved after 2 seconds. And if you say reject, let me define okay, if you say reject, it will hit the inside catch, promise resolved after 2 seconds, right? So you can only resolve and reject promise once. You can, if you try to do it multiple times, it will ignore the remaining promise, the remaining reject or resolve conditions. It is going to hit only the first condition, whether it is resolved or rejected. So it will after print to it will print 2 after it will be getting printed after 2 seconds. So that is how you consume a promise. So let's say we are given a problem statement. Let's define it as a problem.js. First is, let's say, get up. We want to print get up in the morning. This is the first condition. This is the first statement, and we want to print it after 10 maybe 2 seconds. Then go to gem. It will be printed after 1 second, and eat breakfast. It will be printed after 1 second, and we want to do it using promises. So how can we do so? So const p1 equal to new promise resolve reject set timeout resolve get a in the morning, and it will be printed after 2 seconds. Now we need to do something like this. Go to gym, and these are the three promises that we need to consume. So how can we consume them? P1 dot then data will be coming, and we will be console dot logging the data. Now what we can do is we can write something like p2 dot then. Once first promise is completed, then we can write p2 dot then, and we have to use catch as well for catching the error if there is any. But as of now, we are just simply resolving the promise, so we can skip writing the catch condition, but it is a good practice to write catch inside of each and every promise. So you can see that it is growing, but it is going towards the typical problem known as pyramid of doom in asynchronous callback functions, right? So to avoid this, we can use something known as promise chain. If you try to run it, it will run simply, it will run well. There is no issue in that. Right, get up in the morning, go to gym, eat breakfast. So one, two, 1, 2, 3. Right, so this is a problem, right? The code is growing horizontally. That is not a very good way. So you can do is you can return the promise, then use the then and data console.log data, then you can again return p3 dot then data console.log data, and after all of it you can write a catch condition for everything. If there is an error, then it will hit the catch condition, catch block. Right. So that is how you can consume a promise and return. So then we'll return a promise, then it is going to be chained up with this. It is returning a promise, then it is going to be chained up with this, then, right? So that is how it is working. Now we will see promise methods. Right, so promise.all resolves the promises if each and every promise is resolved, and it will give you the value in form of an array, right? In the same order in which the promises are passed, right? So promise.all, then we are writing promises, then we are hitting the then condition. So each of them will be triggered parallelly. So at max it can take 3 seconds of time. So 1, 2, 3, right? So this is getting executed. Now what if we reject a promise? then it is going to say that hey, this one is rejected, so I will reject all of them. So even if some promises are resolved, it is simply going to reject the promise, saying that if we want to pass a different string, that we can do so. Promise 3 is rejected. So after 3 seconds, 1 2 3 3 seconds, promise 3 is rejected, and you will hit the catch block basically, right? So that is how promise.all is working. Resolves the promises if all are resolved, it will go to the catch block, right? If any promise is rejected, then it will go to the catch block. Now there is something known as all settled. It will print the value for each and every promise separately. All settled. Right, so 1 2 3. So for first it is saying fulfilled, and for third one it is saying rejected, and along with the reason. So if it is a fulfilled promise, then you will get the value, and if it is rejected, then you will get a basically it will always hit the then condition. So you can write then, you will write catch right. So it will always go inside the then block, right? Even if any promise is rejected, it is going to go inside the then block and print the value for each and every promise separately. So even if I resolve this, it will give me the value status with the promise, with the array status and value, right? So I'm rejecting it, so I will do reject. Now there are two more methods. The first one is raise. Now raise says that okay, the first promise, whether it is resolved or rejected, it will go to that. The value will be depending on that. So first promise that is getting resolved or rejected is get up in the morning in 2 seconds. So if I say reject, so it will say promise is getting rejected. So first promise that is going to be fulfilled. Fulfilled means two things. It is either going to be rejected or either going to be resolved. Fulfilled means two things. Right. So the first promise that you are getting the value from is getting rejected. So it will hit the catch block and put the error inside it and print the message. Promise 3 is rejected. Right. So it resolves or rejects the first promise that settles or fulfills. Right. So this is the case for raise promise.raise method, and if we write any, that means first promise that is resolved, aggregate error if all promises are rejected. Right. So it will go to the first promise that is being resolved. So I will write promise.any get up in the morning. It's the first promise that is getting resolved. So if I reject all of them, then it is going to throw an error saying that no promise is getting resolved. You will get an aggregate error. After 3 seconds you will get an aggregate error saying that all promises were rejected, right? So these are the four important promise methods that you can use to consume the promises, right? Now we will see the polyfills of them, of each of them. So I will write polyfills. Let me take a quick break. I will be back in a couple of minutes. Okay. So yeah. Let me see the string that you can use to consume the promises. Right. Now we will see the polyfills of them, of each of them. So I will write polyfills. Let me take a quick break. I will be back in a couple of minutes. Okay. So yeah. Let me see the string that you can use to consume the promises. Right. Now we will see the polyfills of them, of each of them. So I will write polyfills. Let me take a quick break. I will be back in a couple of minutes. Okay. So yeah. Let me see the string that you can use to consume the promises. Right. Now we will see the polyfills of them, of each of them. So I will write polyfills. Let me take a quick break. I will be back in a couple of minutes. Okay. So yeah. Let me see the string that you can use to consume the promises. Right. Now we will see the polyfills of them, of each of them. So I will write polyfills. Let me take a quick break. I will be back in a couple of minutes. Okay. So yeah. Let me see the string that you can use to consume the promises. Right. Now we will see the polyfills of them, of each of them. So I will write polyfills. Let me take a quick break. I will be back in a couple of minutes. Okay. So yeah. Let me see the string that you can use to consume the promises. Right. Now we will see the polyfills of them, of each of them. So I will write. It is either going to be rejected or polyfills. Let me take a quick break. I will be back in a couple of console.dir. Right, so we will be discussing polyfills. So these methods. So we can write promise.myAll, and we can call promise.myAll equal to what is it going to accept is a function, and it will require promises, right? Now there will be an array of promises that will be passed to it, and what it is returning a promise that we can fulfill via then and catch. So we will return a promise out of it, return new promise, and it will accept, resolve and reject, right? So if any promise is rejected, it will go to the catch block. So we will what we will do is let result equal to new array and promise count equal to 0. We will iterate over the promises dot for each. We will get a promise and promise dot then result dot push val promise count plus plus dot catch error reject with the if promise count equal to promises dot length. If all the promises are resolved, then we are going to return our result array. And if any of the promises rejected, then we will simply reject upfront. Right? We will not be iterating over the remaining promises. If we get any rejected value, we will simply reject upfront. If we complete all the promises are getting resolved, then we will resolve it. So let's hit the run button, and I think it should work fine. Right? So it is saying promise 3 is rejected. But if I write resolve, go to gym and resolve, eat breakfast, and I will comment out this one. So it is going to give me a result of array. Right? So we have implemented the polyfill for all method. Now we will be writing polyfill for all settled. Promise dot all my all settled function of promises. It will also return a promise that is going to be resolved or rejected. That will not going to be rejected, right? So you will have a result array with you and promises dot for each promise dot then value dot catch error dot finally. If we hit the finally, then we will resolve the result. If we are inside it, what we are going to do is we'll run this and check what the values are there in the array. Status and value. If it is a resolved promise, status and value. So result dot push status fulfilled value is value, and if it is an error, then result dot push status rejected, reason will be error, and finally we will be resolving the promise. Right? So what we are doing is we are iterating over each and every promise. We are getting the promise. If it is resolved, then we will push inside the array using the status and value in the object, and if it is rejected, then we will do status and reason, and finally if all the promises are done, at the end we will do resolve. Right? I think we need to maintain a count as well. Yeah, there is some issue with it. Basically we can maintain a count. Count is 0. What variable did we use in the previous one? Promises count. Okay, so we will use promises count if promises count equal to promises dot then we are going to resolve result and we will use the same thing inside catch block and we will hit the run button. Then it is going to work just fine, right? So this is how you implement a polyfill for all settled, and the remaining are race and any. So we will firstly implement the race polyfill. Now what does it do? Race polyfill, race method does what does it do? Race method resolves or rejects the first promise that settles. Though whether it is resolved or rejected, it doesn't matter. It is going to resolve and reject the same whether depending on its fulfilling condition. So promise dot my race equal to function will accept a promises array, will return a new promise, resolve, reject. So promises dot for each promise dot then resolve reject, right? If promise dot then we will be resolving it. If it is hitting the cache, then we will be rejecting it. So I can do my race. It is saying promise 3 is rejected. Okay, so what if we resolve it? Eat breakfast. So it is going to say eat breakfast. Yeah, so it is working fine, right? So this is the polyfill for race method. Now we'll be implementing for any. Basically it will throw an aggregate error if all the promises are rejected and resolves the first promise that is resolved, right? So what we can do is we can write promise dot my any equal to function. It will accept array of promises, return new promise, resolve reject, let promises not equal to 0, promises dot for each promise dot then resolve the promise. If if we are inside the cache block, we will check whether the if it has not been resolved and promise count is equal to promises dot length, then we will reject it. Will increase the count, and right, so this should be my any and we are good to go, I guess. Right, we are rejecting each and every promise. Okay, there is some issue with okay. What error did we throw up here? errors dot push error reject new aggregate error. Errors, all promises were rejected, I guess. I think they should work fine. Yeah. So we are done implementing all the polyfills of each and every promise method. We have also seen the chaining of promises. How does it happen? Now we will be seeing async await. And how is it? We will be talking about the differences between async await and promises. So async await is a basically sugar coating over promises that was introduced in 2015 in ECMAScript 6 version. Now we will be talking about that. So intro.js. Right. So what if I write console.log before and write console.log after? So what is going to happen is JavaScript is single threaded. It is going to print out before. Now it is expecting a promise to get resolved. Now it will be pushed inside the callback queue. Micro task queue in this case. Promises are pushed inside the micro task queue. Set timeout and set interval are pushed inside the callback queue. Micro task queue is having the higher priority. So first of all the promisified promisified code is getting executed. All the callbacks will be pushed inside the call stack once the main thread is done executing. So we will hit before, we will hit after, and then after 2 seconds we will be getting this value inside. Basically we will be getting the rejected value, so we will be getting inside catch. So before, after, and then 2 seconds after 2 seconds we will be getting the rejected value inside catch. Promise resolved after 2 seconds. Now this is the case for promises. Now how does async await differs from this? So I will write the async await version for this code. So you are using the promise, you write the promise inside try and catch block. So in case if there is an error, then we will console.log error, and there is result, then await p1 console.log result. Now this is the synchronous way of writing code. Before, then we have a pause, then we hit the rejected value. Resolved value, promise resolved. Instead I should say rejected. Will be inside error, inside the catch block. So you see there is the whole code got blocked. So this is the synchronous way of writing code, right? Using async await. You write a await in front of a promise. Then it is going to suspend that particular function at that point of time, and it is going to execute the remaining code, right? It will suspend that particular function, but it will continue with the main thread. But since the main thread is written inside the main thread, so it will block the main thread at that point of time. Suppose if we are writing inside a function, if we are writing this inside a function consume promise. If we write it like this, and we need to define async out of it before writing the function keyword. So async function, whenever you're using await, you need to use the async keyword in that function. If you are writing inside the global script, then there is no function, so you can directly use the await keyword over there. If you are writing inside the function, then you have to use async keyword. Now what will it do is it will suspend the execution of this function at line number 16, but will continue to run the global script. So it will, what will it do? It will write before, after, then 2 seconds. After 2 seconds, it will give us the result. Before, after, it suspended the execution of that function, and it then resumed it after 2 seconds, right? So this is how async await is different. In case of normal promise, it is not going to get blocked. But in case of async await, the function is getting blocked. So this is the synchronous way of writing code. So that is the crux of it. That is the main difference between async await and promise. Promisified code is not getting blocked, but async await code is getting blocked, right? Suppose we are using another promise, resolve const p2 equal to new promise, resolve reject, set timeout. Suppose we are writing this, resolve reject now what will be the output for this? Result 2 await p2 console.log result 2. So what will it do is, it will take up all the promises that are written with the await keyword and execute them parallelly. So P1 is getting executed at the same time and P2 is getting executed. Until and unless this promise is getting resolved, this will not get resolved. So they are both running parallelly, but until and unless the first promise is resolved, it is not going to execute this one. So we will get, after 2 seconds, we will immediately get promise 1 resolved after 2 seconds, then immediately we will get promise 2 resolved after 1 second, right? So 1 2, it is not working like it will wait here for 2 seconds, then it will wait here for 1 second. It is not happening in this case. All the promises are running parallelly until and unless first promise is resolved. None of the promises written below will be resolved. So if I change the condition like this, if I write it before, then what will it do? It will, after 1 second, it will print result 2, and after 1 second, because it is waiting for 2 seconds here, then it will waiting executed after 1 second. If you take up the total time, so after 1 second this is getting resolved, after 1 second again, so total 2 seconds. In total 2 seconds, promise 1 is getting resolved. So that is how promises are working in case of async and await. And async function always returns us a promise. If you try to hit return, then it is going to return a promisified value. Return 2, it will return us a promisified value. Console.log. So it will return 2. It will firstly return a pending state, right? Promise is pending because it has not been resolved yet. So it will throw out us a promise saying that it is pending as of now, right? So that is the case. So I think we are all done up for today. In the next video, okay, let's discuss it in this video only. Or maybe next video, yeah. So that's it for this video, guys. Thank you for watching. In the next video we will be discussing some questions related to promises and async await, right? We have implemented all the polyfills for promise methods, and we'll be talking about debouncing and throttling. Then we will be starting with the front end projects using JavaScript, right? So that's it for this video. Thank you guys for watching.